Thanks for being here. My name is Pierre Felix. I work for Epic Games. I'm a senior technical product manager on the Unreal Engine. Today, I would like to, as well as with Thomas from X-Rite, which will come in soon, I would like to talk to you about one problem that people who work with real-world material have, which is, I have this piece of plastic or fabric in my hands. How can I take, or how can I represent this into a software like Unreal Engine? And that's a real challenge. You know, what's the RGB color of this red or this yellow? Just with the color, it's a challenge. And then when you add more effects on that, you know, the roughness of materials or the bump of things and all that, that's become even more difficult. So one of the pillars and one of the answer to that within Unreal Engine is substrate. Substrate is a new material system that allows you to layer materials together and really recreate physical matter much more easily than before. So you have physically based parameters that you use as input. And the beauty of substrate is that it will allow you to get to different platforms much more easily because there's internal optimizations that will make it easy for you to go from path tracing to high-end, raster rendering to mobile. So this is not a substrate class, but I think it's good to give you some context on how we're gonna, solve this problem with substrate. So it all starts with this main element, which is the substrate slab, which defines material with two main concepts. There's the medium and the interface. The medium is basically how the material behave with regards to its own, characteristics, the volume of it. So it defines how it interacts with light. So if it's transparent, is it opaque? Is this, translucent? So this is where you will control the material through the diffuse and translucency parameters. With regards to the interface, this essentially is about the reflectivity of the material. Is this rough? Is this super shiny? Is this chrome-like where, it reflects light from all angle or only from the grazing angle? So the F0 and F90 will be the main parameter to control that. And then there's optional effects like fuzz and glint. So here are some examples. So here's an example of anisotropy. So you can see how the reflection and highlights can have some directionality. Example of fuzz. So you can also give the very interesting look of velvet, where when you look at the material from a grazing angle, it has this depth effect to it. And then you can control with custom tools, which we refer as the custom specular profile, how the material will behave with regards to directionality from either the view angle or the light. So in those examples, what you have here is a color that is reflected, or we're showing the color changing based on the view angle. So that actually allows you to create very complex effect, such as pearlescent car paints. We're going to get into that a little bit later. On top of this base slab, you have layering abilities. So in this example here, we're using what we're referring as the vertical layer. You can stack materials on top of each other and give them depth. So to create this effect of maybe paint dripping over another surface, or epoxy, being applied on top of a piece of wood and things like that. And you actually define the thickness of those layers with actual dimension, which are expressed in millimeter generally. So other example of the layering capabilities, you can either use vertical layering or horizontal layering, mixing. We won't get into the specifics of that, but that should give you some ideas of the type of effects you may want to use depending on the material you're trying to reproduce. Clear coat is something very easy to do with substrate. Basically, throw on a slab on it and then give it a little bit of relief, a bump, if you wish, to create orange peel effect. And then the same system is also used to create dust layers on car paint, for example. Similarly, there are other effects that you can take from substrate to create this thin film coat effect for iridescence. So soap bubble is an example of that. Or maybe what you see on insects, bodies or eyes, or to create this very interesting pearlescence effect. So if you're working in the automotive industry, one question you may have is, okay, how do I create paint coats? So let's have a look at how a real paint is structured and how you will recreate that with substrate. So if you take a look at a actual physical paint applied on the car, you're starting at the bottom with a primer, and then there's most likely a base coat in which there's metal flakes applied or mixed with that paint, and then a clear coat on top of that. So this creates a fairly complex structure that is multi-layered that will create, what you know as a car paint. In substrate, what you will simply do is stack up 3 slabs for each of those layers. So you'll have, the primer slab, which will be probably very diffuse and gray, and then the clear coat will be something fairly transparent with some orange peel effect or not, depending on the type of paint you're trying to reproduce. So here's an example of interesting paint that was created with substrate. There's also glint effect in substrate that you can use to recreate metal flakes. So if you're interested in knowing more about substrate and what are all the operators and nodes, you can scan this QR code, and this will bring you directly to this documentation page. And I'll leave it for a second, letting you taking, yeah. Okay, so substrate is kind of the backbone of recreating physically based materials in Unreal. But what if you could scan materials and then inject the result of the scan into substrate? So from now on, I will let Thomas get into this topic, and
excellent.
We'll talk to the scanning.
Absolutely. Thanks, PF. Yeah, so my name's Thomas Meeker. I'm 3D solution architect for X-Rite Pantone. And I'm going to jump right in, and I'll explain more about who I am and what we do. So what makes AxF so great anyhow? It's science, baby. We're doing actual measurements of materials. So we're not just simply artistically moving sliders. We're really measuring these materials. And it's become the gold standard for material digital twins. You'll find us in the automotive world, but also in footwear and fashion and architecture and other places. And we do this through using a hardware element, which we have a TAC7 device for scanning, and then we also have our other spectrophotometers, which I'll explain a little bit more about, but basically devices for color measurement. The other part of that is our software called Pantora. Pantora is a software that is proprietary to X-Rite for connecting to our devices as well as measuring materials. So who is X-Rite Pantone? I always ask this question because people are like, is it that Pantone? Like that color Pantone? Yeah, it is actually. And X-Rite is the global leader in color measurement. So X-Rite Pantone, we do color. In fact, we're the art and science of color technology. Where will you find us? We are, you've probably seen our Pantone fan decks. You've probably seen our color checkers. Basically, anywhere where color is important, we are an end-to-end solution, measuring, making sure our monitors are calibrated. You know, anything where color is important, we have a solution for that. So, PF earlier talked about why the AxF file is needed by our customers. Our customers want to be working with real world materials so that what they see is what they get. And this is enabled by substrate that PF was talking about earlier. So substrate gave us the opportunity to really take full advantage of what the AxF file, which is the X-Rite file, has to offer. So the AxF file is a digital twin. You hear that often. It is, for materials, a digital twin of a physical material, compromising full appearance, measurement, information, plus metadata. So I like to show this one, and I always ask, which one's real? Which one's physical? Or which one's physical and which one is virtual? Maybe you guessed it right. So virtual and real. I was looking at my other slide over here. We did this with a comparison with V-Ray and Maya against Canon 60 DSLR. And what we did is we just set up the camera just like, or set up the V-Ray scene just like the camera to do a true comparison. So again, making that digital twin. So what makes up the AxF file? So these are all those texture maps or characteristics about a material that you're used to seeing, right? We all work with diffuse maps, normal maps, height maps. We are creating with our scanning technology all of those different maps. So no need to get artistic. We're just doing a measurement and creating the file. And that output file is the AxF appearance exchange format. This also contains measurement data because we are measuring these materials. So cool. Why should I believe? Well, measured materials you can trust when it comes to designing with confidence. So accuracy, and probably most important, is a standardization and giving you that confidence to design. And when I talked about standardization, we want to make sure our file actually looks like that same virtual file inside all softwares. We're talking about Unreal Engine today, but we know there are pipelines where customers are using lots of different tools, and the marketing team may be using Keyshot, and then the product development team is using Unreal. It's really important that that AxF file, that digital twin, reads correctly across the different softwares. So let's talk about AxF and Unreal today. And PF is actually going to talk more about our integration. So how do we measure color? So some people may be familiar with spectrophotometers, but we measure color with a spectrophotometer, which measures sample by shining light on the sample and actually measuring the reflected intensity at each visible wavelength. So from 400 to 7 nanometers, we are measuring the actual color and reflectance of that material. We do this with multiple spectrophotometers. So we have the MetaView on the left, which is a 45-0 device. We have a diffuse device in the middle, which is our sphere technology. And then we have a multi-angle technology, which is used for more complex material appearance, like car paints and anything that has interesting change in appearance based on like lighting angle and viewing angle as well. We also have another device called our TAC7. This device measures appearance by using a lot of different technologies. We are using spectral filter wheels for the color, like our spectrophotometers, but we also have things like a projector, a linear light source, so that we can get the full appearance. So think about this as many multi-angle, where we're getting thousands of different views of this material to create that final AxF. And the real magic behind it is that, we're creating like gigabytes of data, and then we are able to create just a few megabyte file of that final AxF material. So there is definitely the right device for the right job. We started with our TAC7 back in 2016, and then we went and we just said, okay, well, customers aren't always doing every material under the sun. They may just be doing plastics. They may just be doing leathers. So we wanted to bring in some of our older technologies, and I say older in the sense that they were being used for different purposes, and repurposing them to do full appearance measurement. So each device that I talked about earlier, and I'll be showing again here in a second, will sort of hit all of the types of materials that you want to do. And then we have the TAC7 on the right that will do all of them. So the meta view, we talk about this doing any type of like textiles or leathers or plastics, anything with texture, because we can actually use photogrammetry to do the texture with the different lighting angles and pickups. We have our benchtop device. So this is great for volumetric materials, translucent materials. Translucent materials are extremely difficult to create realistically, and being able to do just a simple measurement to actually create an AxF and use in your design work is really, really helpful. And then we have our multi-angle. So the multi-angle is great for all types of materials. We can't do transparency, but we can do most everything else. So we've got car paints. These were measured both with the MAT12, and we've got the car paint, and then we've got a textile as well. So I just want to show you a quick tutorial of our multi-angle. I actually have the device with me this week, so if anybody wants a demo, please reach out. I've got my contact information at the end. So the MAT12 is a multi-angle instrument that has multiple illuminations, multiple pickups of the spectral data, and also a camera for taking pictures of texture. So this is just a quick little tutorial on how this works. There we go. So when I'm doing a measurement, I wanted to show how user-friendly this is. So this is our Pantora software. I'm just going to quickly do a measurement. So in this case, I'm going to choose a car paint, but we could do a BRDF or a textured SV BRDF. I have a few different parameters here. We give you examples. We also give you some help. So for like the car paint, there's a number of different things that you can set. We can even do things like the angular lifetime of the material, or I should say of the flake. And then in the SVBRDF, we want to make sure that we're telling it, does it have a clear code? Is it not coded? And then basically this would be used for textured materials. So in this case, I'm just going to show real quick. So with the car paint, we have a few different options. The primary ones, and I know we've got a lot of automotive people here this week, so I wanted to focus on this one. And they're also really difficult to artistically create. So we're choosing things about the material. Does it have effect pigments? We can show the angular lifetime, like I mentioned earlier. Yes, we can capture how long a flake flashes. And that can be visualized. We have a couple of other options that have to do with measurement data, so being able to get all the spectral measurement data, not just the RGB. And then it's as simple as capturing and then clicking finish. So I'm going to move on to the next one. And then how do we manage the color? So great, we're able to create these wonderful materials with these devices, but I need a way of organizing that data. I want a way of communicating that data, and all of that work is done inside of Pantora. We have tools to help you to, there we go. We have tools to help you create tileable textures, a way of databasing, exporting all the texture maps. There's a number of different things that you can do with the Pantora software. And this is a great opportunity to hand it back over to PF, who's going to talk about now how AxF comes to substrate.
All right.
Cool.
Thanks,
Peter.
Thomas.
Yeah.
So what we've done with the help of X-Rite, we've been jointly developing this together. We have been creating a plugin that will be released in 5.7, hopefully. No promise made, but probably available as experimental this summer. We have made a plugin to create, to take the AxF information and import it as a substrate graph into Unreal without having to, figure out much more than exporting a file and importing it. So here's some examples that were rendered in Unreal that came in from Pantora directly, no fine tuning, just drag and drop the material in and render with the normal, physically based or physically based lighting tools of Unreal, which is either the cinematic camera or sun and sky and all that. So this is really out of the box examples that were not touched at all, other than dragging them in the scene. We're working on car paint. Here's an example of that, and another one that has angular dependent color. You'll notice that flakes are not there yet. This is something that we're currently working on. It's a problem we have to solve at the moment. But so far, we're using custom specular profiles to replicate the car paint appearance exactly how it was measured and represented in Pantora. So how are we doing it? What's the workflow? In Pantora, you have the AxF file that is loaded. The Pantora has an exporter tailored for Unreal Engine that will create a JSON file and a bunch of textures that will be fed into the substrate graph directly. So here's how it works. So in this example, our goal is to take a piece of fabric from Pantora and load it in Unreal. We're going to go in the browser section using the export tab and pick the Unreal Engine exporter. Select the folder where we are going to export this AxF JSON file and click the export button. That's really the only operation that you need to do. If you have a long list of materials to process, a command line interface utility is also available. So as you can see, this JSON file contains parameters that are recognizable by substrate, F0, F90, and a couple more parameters that are included in basically the master material in the plugin. We're also exporting a bunch of textures. And those textures are optimized for memory purpose. So we're using EXR when needed, TGA when needed, and so on. So in Unreal, the process is as simple as taking this file, once the plugin is enabled, drag and drop it in the content browser. An interchange pipeline will pop up. There's no parameter to deal with. There's really nothing you have to worry about. And then import. Material instances are created, as well as a subtexture asset. So let's have a look. So basically, we're pointing to a very simple master material, which has most of the parameters that substrate may want to expose. Roughness, normal, Fresnel, things like that. As you can see, contrary to the existing AxF material importer, the substrate graph that has been created is very, very simple and straightforward. We're also importing the textures. We're going to open up one right here. We're conforming the textures to power of 2 automatically. So again, you don't have to take that into account yourself. And all you have to do is drag and drop that material on your object. The scale in this case was a little bit wrong. You can basically change that. The master material exposed some scale parameters, so we're going to go change that. And there you go. So as you can see, if we compare the Unreal result with the render preview of Pantora, you will see that both materials are virtually identical. So in the Pantora viewer, this is what you get, and in Unreal you get essentially the same thing without having to worry about any parameter whatsoever. So our goal was to make this, easy to use for any designers. Here's another example with the yellow plastic. It's a bit far away. Let's go. All right. As you can see, we're capturing the fine grain detail and orange peel effect that may have been on that material. And here's the side-by-side comparison. The color may vary slightly between the two. It's because the Pantora viewer used a different ICC profile than Unreal. At this point, it's just a matter of, camera exposure, lighting, and color profile. But the raw parameters are the same. There's another example with this red plastic. Same thing. We capture the fine grain effect, and again, you didn't have to worry about tweaking the depth of things and having to figure out normal maps and so on. There are cases where things may go wrong. So here's an example. In this case, the material then came in as tileable. That may happen. It was a piece of fabric scan, and maybe it was misaligned. Maybe there were, some patterns in the material itself that couldn't be very repeated because there's a scale issue. The scanner have a 6-inch or 8-inch size, So things may happen like that. So how do we solve that? So this is the raw material, in this case, that was imported in Unreal. There's obviously tiling issues. Pantora has pretty neat tool to make maps tileable. So the only thing that you have to do is to go in Pantora, find the material editing tool, and there's actually a texture viewer where you can crop, select zones of interest, and then use the make tileable algorithms and filters that are built in Pantora. And at this point, you re-export. And because we're using an interchange pipeline, the re-import functionality that is pretty much standard in most assets in Unreal will just work as expected. So re-importing those textures will fix we'll re-import the generated texture from Pantora and fix the tiling issue. So what's our roadmap? There's still a lot of work to do. This is why right now we're in the experimental mode. We may release this to the public somehow this summer through a Pantora release. And hopefully in the release of 5.7. We're currently working on adding triplanar and parallax occlusion mapping to the materials that we're creating so that it's easier to represent, relief and texture, aligning the materials onto objects that may not have the right UVs. We're also working on making the anisotropy reliable. So far, I didn't have that piece of code working when I was working on the presentation, but I had last-minute images from the engineering team 2 days ago, and they are on the right here. So you can see that the seat belt type of fabric, as well as brushed metals, work pretty well. And then car paint flakes is a problem that we still have to solve. So the density and the color is something we're working on. And yeah, that's it. I have maybe more example. I have a running. We have 20 more minutes to the session. So
Yeah. Want to show the run through?
Yeah.
I think it's worth it.
yeah, I can run it, and maybe you can take some questions.
Absolutely.
Sure, people have questions on
Absolutely.
scanners.
Yeah, and if you want to scan this QR code, I do have the multi-angle device with me to do demos, so I can scan your shirt. I can scan whatever samples I have brought with me, and we can do some tests. So feel free to scan the QR code, text me, email me, whatever you want to do, and we'll set up a demo. Thanks for coming to our talk. Appreciate it. Thanks, PF.
Thank you.
Thanks, guys. Yeah, that was great. Thank you.